We have moved away from working with categorical data and we are moving into quantitative data and how we can display quantitative data. If you remember from the last section, the two main ways that we're displaying our categorical data are with pie charts and bar graphs. If we have more than one variable, the data is displayed in a two-way table or a contingency table. Then you can either make side-by-side bar graphs or you can make segmented bar graphs. Today we're dealing with quantitative data and the two main ways that we display that type of data. You should be somewhat familiar with it, but it's always good to have a refresher. So we're going to be working with dot plots, stem plots, which are also called stem and leaf plots, and then histograms will come in tomorrow's video. We're going to be talking about shapes of distributions, how do we compare them, and then again tomorrow we'll talk about using our histograms wisely. So what is a dot plot? A dot plot is when each data value is shown as a dot above its location on a number line. It's important that you have an accurately drawn number line, and you don't just include the numbers that are present in your data set, but all numbers in between. So you can see an example here of number of goals scored per game by the 2004 U.S. women's soccer team. And notice how we have our number line goes from 0 through 8. That's all we really need for this because the data goes from 0 to 8. Notice how there's also a title or a label on this axis down here. So if I didn't have this data, I could look at this dot plot and clearly read and understand what the dot plot is showing us. So just some basics on how you make one. Draw a horizontal axis. It's typically horizontal. You really won't typically see vertical. Label it with your variable name. You want to scale it from the minimum to the maximum value of your data set. And then mark a dot above a location according to each data value. If your data values aren't whole numbers, it's kind of up to you. Be as accurate as you can. If it's all in decimals, maybe that's how you should scale your number line. The next type of way that we can display our quantitative data is with stem plots, also called stem and leaf plots. So be used to hearing both ways. Stem plots give us a quick picture of the distribution while also including the actual numerical values. Whereas in the dot plot, you just had dots. Now we have the actual values. Okay. So some things to notice. There are numbers. There's a line drawn in the middle. Even if a stem is what this is called on the left, the stems are on the left, the leaves are on the right. Even if a stem is blank, you still have to include it. Just like in the dot plot, we didn't just include the numbers that were there and leave out the other numbers on the number line. We included everything in between so we get a good visual representation. Notice how there's a key. It shows us the context so I can understand how to read it. As far as line 2 means 22, and it's talking about a male student with 22 pairs of shoes. So if you're making a stem plot, you want to separate each observation into a stem, which is all but the final digit, and a leaf. So it's possible that these stems over here might have more than one digit if your numbers are in the hundreds. Write all your possible stems from smallest to largest in the vertical column and draw the vertical line. Write each leaf in the row, and then you want to increase them, or write them in order from decreasing to increasing. That's not a huge deal breaker, but it really does help for something that we're going to be doing later on. So it helps to have these values in order from smallest to biggest. Provide a key. Make sure you have that key and make sure there is context. Right? There's not really a title that's needed. You just need a key with some context, what the stems and the leaves represent. Now, there's different stem plots you can do. Here's a basic example. So this is showing 20 female AP Stat students answering how many pairs of shoes do you have. This is why I'm asking you guys to count your shoes because we're going to make one for our class tomorrow. So we looked at the data. Everything's in the tens. So I see I go from the teens up through the 50s. So my stems will be 1 through 5. Then I go through and I would cross out and figure out what my leaves were. Put them in order. If you want to kind of eliminate this step and put it in order as you go, feel free. Notice how there's no commas. You do not need to put commas. It's actually discouraged from putting commas in between your numbers. It's understood that these are all separate numbers. And notice how we have multiple repeats. It's okay if it repeats more than once. It shows us the actual data value. So if I wanted to work backwards and take my stem plot and recreate the data numbers, the data set, I could do that because I have all the numbers here, right? This can tell me how many there were. If I count up, there's 20 of them. There should be 20 females. And then the most important thing is my key, showing how you read it, and the context. Context is very, very important here. Now, there's two special types of stem plots you might see. There's what's called a split stem plot as well as a back-to-back stem plot. A split stem plot happens when you split your stem. So instead of just listing, like in this example, for instance, if instead of listing just 1, 2, 3, 4, 5, I could have listed 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then split the numbers down the middle. Between 0 and 4 for the first, and then 5 through 9 for the second. This is good when your data values are really bunched up. So for instance, if you only maybe had numbers between 0 and 30 or 0 and 29, it could be a little hard to see patterns just by glancing at it if they're all bunched up. So you can split the stems in that case. Another option, if you're comparing two sets of data, two sets of quantitative data, you can make what's called a back-to-back stem plot. It compares two distributions of the same quantitative variable. This is helpful just for visually comparing. You can see, oh, there's a lot of men down here, not a lot of women down here. The women go way up here, and the men don't really as much. Still having a key for each one of these. Okay, still having our key and seeing the difference between the two. So this is just a reminder of how we make our stem plots and how we make our dot plots. So remember how to do those, and we will actually practice making them in class tomorrow. The next video that you're going to watch after this one is showing you how we can maybe compare and describe this data set.